Hello, hello, hello. Welcome back to our second session of Sunday. We're going to wrap up our CCNA Bootcamp with this session. All that good stuff that goes along with it. Good stuff. So I'm going to I have not tested the polls out here on this, but I'm going to throw out a quick poll. I'm going to create a poll real quick. Echo's gone now. Oh, okay. Weird. Question. How was this experience? Do it again. Waste of my time and money. Change how it was delivered. Content. And I'll add another answer and like all good. Need to come again. Actually, that's the first one answer. All right, so I'm going to go ahead and I'm going to make this visible. And I'm going to add the poll. You guys can answer it and go from there. So for those of you who would do me a favor and provide a little bit of feedback on how you thought the bootcamp went, because this is my very first time how that was done. Can we vote for more than one thing? I don't know. I've literally just created it. So I don't know what the option. Okay. Good stuff. Okay. Fair enough. Okay, so clearly you guys would have wished things were done differently in terms of the content. And could you give me a little bit of clarification? I think Michael, is this service? Okay, so that's another thing I was going to ask. I should what would the changes be if you were to be done? Would you prefer it be? My goal is to switch over to YouTube and do it on YouTube. I think YouTube's got does a little bit better of a job at this type of stuff. They are an actual platform, so there's that. There's a little bit more of a delay, but if you could give me some insight as to what you would have wanted to see differently done, so like done through YouTube instead, or the video would crash. Okay, I gotcha. So having EVNG working before you start would have helped. I gotcha. I think that's what you mean. Yeah, so that's going to be, okay, that's fair. Yeah, it's now that I've done this once and it's gone pretty well. So I think that in the future I will do things a little bit differently. We'll have some more information available before we get started, obviously. What does it just use over packet tracer? Gotcha. Yeah, it's going to be one of those things that I'm going to put a kind of like a not a prerequisite, but a recommendation. Gotcha. Okay. Yeah, I'm going to, if you just barely got it up. Gotcha. Okay. So there's a couple of YouTube videos that I put out that are focused on, sorry, I've lost my train of thought. There are a couple of YouTube videos that I've got setting up Eve, and I suggest you guys go over there go on my channel, do a search, type in Eve, and pull up whatever content is relative to it. And I walk you through how to set everything up. So it's pretty straightforward from that perspective, but it's one of those things where you're right. Would have been easier to follow along if everything would have been already set up. And yeah, so but overall, okay, cool. That's what I'm looking for. Much easier to follow along by doing it with you. I got you. Awesome. Well, I'm glad that it worked out for you. Was the pace too fast? Did I go too quickly at any point in time in terms of the deployments that I was going through, where I was starting to lose people? Yeah, you're a bit quick at points. Okay. I tend to get a little quick when I'm bouncing back and forth and I'm trying to doing like a transition of going from static routing to stuff like that. I gotcha. Well, the fortunate thing is in the next couple of days, you guys will get to watch the replays on YouTube, and I'll post them, and they'll be the CCNA Bootcamp Saturday session 1 and 2 and Sunday session 1 and 2. So you'll be able to watch and go from there. But that helps because a lot of these commands I'm comfortable with, and so that's on me to slow down. So, and it's kind of hard to do that type of stuff and go super slow, because I'm just I get in the groove and I just go. But yeah, for sure, Pete. I'm sure you'll get that all squared away here pretty soon. You'll be good to go. I'm going to transition over to YouTube, I think, for the next round, and I am not going to charge for the access to the sessions. I'm going to make those free. So this was kind of a one. I tried this out. I didn't get a lot of great feedback. So from people that I was trying to get on, the people that are willing to pay to come sit on one of these sessions, you guys specifically, that worked out pretty well. But I think moving forward, I'll probably use YouTube, and then I will anything that's in the platform or anything that I'm going to be adding to the boot camp or any of the live sessions that I do. I don't know if I'm going to necessarily call it a boot camp, but it'll be like live sessions, and you guys can come, ask questions and things like that through YouTube and stuff like that. Any of the material that I create, Eve topologies, the configurations, all that stuff will be available in the membership area. So you'll just be able to pay the $10 a month, and it'll be barrier to entry. It'll be a little bit, a little easier to chew on. I get a lot of complaints about people not being able to afford it, and that's fine. If you can't afford it, that's all good. You guys are here, so obviously you could afford it. So I do appreciate you guys stopping by and putting your trust in me to help you prepare for CCNA. So hopefully the stuff that we covered helped you move that needle closer to a pass than put you further behind. But and everybody got the $100 thing, as I never raised the price back up to $250. So, but in the future, I'm going to probably just go and I might do another one where I may charge $25. I don't know. I'm still trying to figure that out. But with that being said, I do appreciate everybody coming to our boot camp and stuff like that. So with that being said, we're going to dive into OSPF in this section here. And I'm going to cover some of the high level details real quick, the different multicast groups, and go from there and get that running. And then we'll talk more about access lists and talk about how they come into play and how you can filter and stuff like that. We're not going to get into super, super deep detail. My goal was to have all the sites working, but I'm kind of glad that I didn't. I'm glad that I slowed down and I only focused on the specific areas and making sure that I didn't leave anybody behind, slow the pace down, charge more for CCNP and CCA content like all the other platforms. You know what? You're probably right about that. And that's something that ironically, I'm glad you guys are saying that and not me. But that's actually my goal, is anything that's going to be more CCNA oriented, I'm going to keep the price relatively inexpensive. But if you're looking to dive into accessing content for more advanced networking skills, whether it's Cisco, VMware, or otherwise, I probably will charge more, 25 or 50 bucks a month for CCNP, CCIE training. Ironically, my personal direction is VMware right now, and it's been like that for, I don't know, probably 5 or 6 months now. So at some point in the future, I'll try to get more content out, but I really don't want to do pre-recorded videos anymore, like where I'm having to record the videos and then upload them, stuff like that. It's very time consuming to do that. I'd rather get on here and just talk about the technology and answer questions that you guys have. We'll definitely be back to the VMware content. Okay, so you want to see VMware content live? Sure. Just be aware, and I don't want to take up too much of the beginning part of this session with just mumbo jumbo stuff, but just be aware when it comes to VMware content. I have no problem going live and doing some VMware training and stuff like that. I really enjoy VMware, actually. But the only drawback to it is that when you're dealing with VMware training, things like installing vCenter server or installing ESXi hosts, that is a time-consuming process. So I would just have to come up with a game plan of talk about whatever it is that I'm doing, and as I'm talking about it, be going through the deployment. So installing vCenter server takes about a 45-minute process, depending on the platform. If I deploy it directly on a server, it goes much quicker, 15, 20 minutes, but it is a time-consuming thing. So it'll be one of those things where, like, if I was to do a live stream, I'd have to like come up with some filler topic for 10 or 15 minutes, something like that. I wouldn't be able to talk about all the theory up front and then sit there and just twiddle my thumbs. So I'll have to figure that out as we move forward. But as a matter of fact, I am just about done recording my NSX-V for vSphere series, and I've got about 30 something videos recorded for that. And then I actually just bought 2 books for VMware NSX-T, the new version of NSX, and I'm going to begin recording content for that here starting next week and getting that, because I have 2 different environments set up, one for V, one for T. I'm going to start getting that stuff rolled out. So you'll get to see some technology rolled out for it, and that'll be pretty cool. I'm actually really looking forward to that, getting that stuff knocked out. And then once I have T knocked out and that recorded and all that good stuff, my goal is to then start diving into desktop mobility. So good stuff there. I want to become one of those rock star VMware engineers as well. So, all right, without any further ado, let's dive into OSPF. Let me go ahead and share my screen. Screen 3, go ahead and get this party started. And let me close this message. All right, so I will first, before we dive into the content, I do want to thank everybody for their feedback. That's important to me, because what I think works and should be a very smooth operation may not be the case for you guys. So I do appreciate that. And what we'll do as we move forward, I like open and honest. Be transparent with me. Let me know honestly what you guys think on stuff, because what I think works may not. So, but I do appreciate the feedback. So with that being said, we will dive into OSPF. So OSPF is probably one of my favorite protocols besides BGP from an operational perspective. It's very, very easy to get working, and there's some cool stuff that comes into play with how it works and stuff like that. But you need to, I'd say, if you were going to learn dynamic routing in a crawl, walk, run, or start from A and get to Z, I'd say that RIP is the easiest one to understand out of the gate, and then EIGRP, then OSPF. Because if you understand EIGRP and you get that down pat, then OSPF will be very, very similar to EIGRP. Some slight differences, but on how the protocol works, the different multicast groups and things like that. But for the most part, OSPF and EIGRP are very similar operationally. So it makes it very easy to deploy and get working. And then once you understand OSPF pretty well, ISIS is the same algorithm, so the shortest path first algorithm to get working, and it doesn't do as many things as OSPF does. OSPF has a crap ton of nerd knobs, and I'll show you that when we get on the CLI. But it's definitely a couple of protocols that if you go in that order, RIP version 2, EIGRP, OSPF, ISIS, and then dive into BGP, it'll make all the routing protocols pretty easy. And to be honest with you, if you start grasping the concept and the understanding of how the routing protocols work that way, it'll be that much easier. You'll see that you'll start to pick up the pace of your learning because you'll already understand how something works over here, say like how adjacencies are formed. You'll understand how that works in OSPF because you'll pick up on it right away with OSPF because you already understand how it works in EIGRP. But once you have that base foundation and you add that layer, it'll just be adding another layer and another layer, and you'll be able to pick up on things much, much quicker. So hopefully that makes sense. So with that being said, the cool thing about OSPF is it's open standards, right? It's open standards, and it allows any vendor to run it. Right. So I've worked in several environments where I've had a situation where I'll go ahead and change my color over to be green so it's easier for you guys to see. I've had several deployments where I've had a Cisco router, right? I'll just say a CR here and a CR here. And then I've got connectivity to a couple of like a stack of Cisco switches. So I'll draw this out like this. And these guys are stacked together, and these guys are connected to here like this. And then you've got some like Palo Alto firewall and a Palo Alto firewall. And these guys connected like this, right? So I've deployed a lot like this, and you end up having to form OSPF adjacencies like this, right? You get all your adjacencies up and running, and you have a kind of an HA deployment scroll deployed. So in this case here, it makes it really easy to roll that out. And then you can have multiple connections set up. And then this is actually very common where this little section right here, and I'm not going to get too much into design, but this little section of connectivity here is a very small public address range, public IP space, where let's say, for example, you go out to there's a place on the internet called IPv4 auctions.com, and you can buy subnets that are no longer needed by an organization, and you can, I'm not sure how often it's that, this is the last place I remember looking for IPv4 addresses, but I've bought /24s for customers in the past. Obviously they're paying for it. I'm just going out there and grabbing the subnet range. So let's say, for example, you grab the 131.0.0.0/24 range, right? What's cool about this is you can actually take the very end of the range. Let's say you break it down and you have 1, 2, 3, 4 devices, right? So you need to have, at a minimum, you're going to have one connection here. So it's going to be .1 and say .2. You're going to have another connection down here. These could be, you don't have to have them all separated. You could have VLAN separation here where CSR1 or Cisco router 1 and Palo Alto 1 are one subnet, and that's in point to point, or you could do it a couple different ways. I often recommend, since you've got 4 devices, you would need like a /29, right? /29 address range, and then you give this guy .1, this guy .2, this guy .3, and this guy .4, and then this is a end of the range type of configuration where you're going to go and break it down, and then you take the very last 6 IPs of your range. You just advertise, you pull a /29 off the back end of your 131 address. It'll be like 131.0.0. What would that be? 248. Yeah, 248 through 254, right? So you'd grab these last 6 IPs off your range and you dissociate them here. And then by doing that, you would be able to have, for example, this would be your NAT router, right? And you would have inside and you'd have outside, and then you'd be doing all your firewalling on your Palo Altos. That's just one example, but this is where you would use OSPF because it provides that inter-vendor communication. You'd be able to set up a OSPF pairing between the Cisco box and the Palo Alto box, and that's where that type of stuff comes into play. That's why I really like OSPF, because I don't care who I'm pairing with. I can do whatever I want, especially in a data center. This is huge in a data center because more often than not, I'm going to be dealing with with more than just Cisco, right? Oh, and by the way, if I'm running, let's say this is a data center, and behind my CSRs, I have not my CSRs, but behind my Cisco routers, let's say I have Nexus switches, right? And they're connecting up to the Cisco routers. What I might have behind my Nexus switches are ESXi hosts. And on those ESXi hosts, I might be running NSX-V or T. And guess what? NSX-V supports OSPF and BGP. NSX-T and 3.0 just supports BGP, but in 3.1, it supports OSPF and BGP. So I'd be able to route from my edge down to my ESXi host through dynamic routing. So if you're following what I'm trying to lay down here, once you learn how the protocols work and how you understand their interoperability and communicating between the different vendors, I could have one OSPF adjacency, or not, I shouldn't say one OSPF adjacency. I could have connectivity from my ESXi host to my Palo Alto firewalls, all running OSPF, right? And that's where the beauty of having a protocol that's vendor agnostic. OSPF runs on everything, BGP runs on everything. It makes it really, really easy to do that type of stuff. So the reason I bring that up is because you might walk into an environment where EIGRP isn't the way to go. It's not the way to do it, because you wouldn't have the all Cisco environment to work with. So EIGRP is great. It works really well, but there are potential issues with it. And one of them is not being able to work with other vendors. So keep those things in mind. I'm going to go ahead and clear the screen off. Now, OSPF works very, very similar to EIGRP. So if you have R1 and you have R2, I'm going to use the same example I used before, and there's a LAN segment sitting behind it. You're going to have a connection between these guys. This guy's going to be 10.1.2.0/24. This guy will be .1. This guy will be .2. And you're going to use the router OSPF 1 command. Now, the number here is arbitrary. You can use whatever you want. This right here is just a process ID, right? It's not the same thing as an autonomous system number. There are two different concepts. This is a local process because you can have more than one OSPF process running on a router, and you can redistribute between them as well on the same router. Where if you're coming in underneath here, the network statement is identical. You type in network of say 10.1.2.0, 0.0.0.255, but then you need to add in one more additional statement, which is the area identifier. We'll say area 0. Area 0. What is area 0? What is an area? An area is a flooding domain. So an area in OSPF is to OSPF where a autonomous system number is to EIGRP. It's how far we're going to let our routing updates propagate. And what is our administrative domain? Now, the area isn't specifically tied to the administrative domain, because you can have multiple areas inside of OSPF, and they're all the same autonomous system or the administrative domain. So I can have R1, R2, R3, and then R4 all in serial or all in a line. And I can run OSPF area 0 between R2 and R4 and R3. And then on R2, I can have another area over here. I can have this as area 1, for example. And then this guy right here, when you have multiple areas, would sit between area 0 and area 1. And any router that sits between two different areas is referred to as an area border router because it borders two different areas. You need to, in order for an ABR to be an ABR, it needs to have at least one interface, specifically this one right here, inside of area 0. And then once it does, it can have an interface in any other area that's non-zero. So 1 through was it 4.2 billion? I think it's something ridiculously high. Now, from a area nomenclature perspective, 0 right here, if you type in area 0, it's actually going to look like this. It's going to be a 32-bit address or a 32-bit identifier, and it can be documented either as a 0.0.0.0 or a 0. Now, if you want to make this area 10, you can make it area 10, or you can make it 0.0.0.10. It's up to you and how you want to define it. Irregardless of how you define it, it is an identifier, right? And that is the key thing to keep in mind here. The area is the only thing different between OSPF and EIGRP, and it's similar to the autonomous system, but not the same in terms of being an administrative domain. Yeah, the autonomous system is the administrative domain. The area is the flooding domain. So in that case, that's where they're the same as the flooding domain, how far you're going to send routing updates. Now, they work the same way in terms of how you set them up. So you type in router OSPF 1, and then a network of 10.1.2.0, 0.0.0.255 area 0. You do that on both sides, right? You configure that on R1. You configure that on R2. What's going to end up happening is they're both going to send hellos out the interface that's configured with the IP address of 10.1.2.x. That's still the same as it was for EIGRP. The only difference is they send to 224.0.0.6 for the designated router and 224.0.0.5 for all non-DR routers. So what that means is I'm going to send by default on a connection between two different routers that are connected to a multi-access interface, or they're connecting, you plug a router into a switch and that switch also connects to another router. That's a multi-access interface. You're going to run, if it detects Ethernet, it's going to automatically run that into the broadcast network type, and it's going to send all of your updates to this guy right here because you're going to have a designated router election process. What's a designated router? A designated router is going to be the device that handles all of the routing updates in the environment. So whoever wins the election, whether it's router 1 or router 2, will be the device that all the routers in that subnet that are connected to that LAN segment. So you might have R3 up here as well. You might have R3 that connects into here like this, and this would be .3. In this case here, you're going to have one DR, and let's say that R2 becomes the DR. You're going to have one router that becomes the backup designated router. We'll say that's R1, and then R3. If R1 and R2 have already been elected as DR and BDR, R3 will come in as a non-DR or a DR other. So what ends up happening then is if R3 has a LAN segment that he needs to advertise, he's actually going to send that update to 224.0.0.6. 224.0.6 is going to come to router 2 because he's the designated router. And then what will end up happening is R2 will then go ahead and receive that update, and then he'll push that update to R1. R1 will get the update. R1 will always be kept up to date via R2 through any updating, and this will actually be a unicast update. Updates are propagated via unicast to all the devices. And then in the event that R2 goes down, R1 will then be promoted to designated router, and then R3 will be promoted to backup designated router because the election process will kick off. And R1 will then be able to disseminate information just like R2 did. And that's how the DR process works. Now, is there any real value of having the DR? There is not. So if you have connections like this, and you have multiple routers sitting on it, and it's then the broadcast network type and the DR makes sense. But most of the time, you're not going to have this type of a setup. You're going to have something that's more like this, where you're going to have a point-to-point link. And what you're going to do, in order to remove the DR process from your operations, you're going to go to the interface level here, and you're going to type in the command IP OSPF network point-to-point. If you go to point-to-point network types on both sides, they both have to be the same configuration where you get a network type mismatch. You do that, they're automatically going to get rid of the type 2 LSA. The DR process goes completely away, and you are no longer running a DR. And that's the ideal situation. And I'll show you guys how to set that up on R1 and switch 6 so you guys can see the difference between the two. If you are running a scenario where you've got R3, R2, and they're connecting down to R1, and you've got a LAN segment connecting these guys together, then a DR process would come into play, but you don't have to use it. You can actually use what they call point-to-multipoint, which is another point-to-point option. So you've got a single point, and he points to here, and he points to here. So you can run also a network type of point-to-multipoint. That's another option as well. And then it forms adjacencies with both guys, and the updates go back and forth like so. If you have the ability of running EVE-NG and you have the ability of running OSPF, I would suggest testing out all the different network types. A lot of organizations that only have point-to-point connectivity between their infrastructure devices will automatically go to point-to-point. OSPF network type point-to-point is probably the most common deployment that I've seen. It's very rare to see network broadcast. There's a couple other variations as well. And just so everybody's aware, when it comes to a similarity perspective on the network types, you have broadcast and non-broadcast multi-access. For those of you that have been around for a while in the IT space, this was what frame relay was commonly referred to as, non-broadcast multi-access. Non-broadcast, meaning that multicast was not supported over the transport, where only unicast communication was allowed. So you would have to use a different type of situation. And if you had, we'll say this was a frame relay network over here, you would use point-to-multipoint non-broadcast as your connectivity, which would mean that you're only allowed to use unicast communication. So there's no multicast hellos being sent. And then, so these will work together because you still have the DR BDR process coming into play, where point-to-point, point-to-multipoint, and point-to-multipoint non-broadcast are all similar as well. So this is the determining factor. Broadcast and non-broadcast multi-access will work together, and any version of point to anything else will work together. But if you tried to run point-to-point and broadcast on the same LAN segment, it would not work. So just keep things like that in mind when you are looking at how the operations come into play and things like that. So that is some of the basics that I wanted to cover in terms of the operations. Is there any questions before we dive into the config? Because the config isn't going to be very involved. It's going to be setting up a couple of network statements, doing the passive interface between these guys right here, like we did with the EIGRP, and getting the default route propagated and all that good stuff. Any questions anybody has? Clear as mud, maybe. I don't know. Well, I'll let you guys give me the feedback. And I'm going to go on a limb here and say that you're probably going to have to go over this a couple times and lab this stuff up in order for it to really click. I know I did. I understood the logic to it. I mean, it probably makes sense, but it might be the first time you're hearing some of this stuff. But you definitely need to dive into this stuff a bit more and do some hands-on labs. So kind of beating you to the punch there, Pete, because I know that's your typical response. But I know you're on the right track, though. Anyway, no questions? Good stuff. With that being said, I'm going to go ahead and clear the screen off. If you are typing your question in, go ahead and pose your question, and we can handle that. If not, I'm going to go ahead and get the configuration going. I'm actually going to... Can you touch on the different types of LSAs, or is that not so important? Yeah, I could touch on them real quick. Let me clear the screen because I kind of ran out of space. But yeah, I can touch on those real quick. Not a problem. So there's a couple different LSA types. So we'll take a look at type 1 first, which is going to be the router LSA. LSA stands for link state advertisement, or it's the advertisement of a link on the router. What's a router LSA advertising? The connections here, the VLAN interfaces, stuff like that. That's what it's advertising. It's advertising the physically connected or logical interfaces that are on the device. That's what a type 1 LSA is. Type 2 LSA is the network LSA. I'm sorry, where's that summary? I honestly don't remember. I always get confused on that one, if it's network or summary. I'm going to go and say summary. I think is the correct answer. Well, we'll find out when we get on the box. So I can't remember off the top of my head, but I'm going to say summary. Summary, yeah, that's what okay, summary is type 3. Yeah, okay. I knew I was in the right direction. I was pretty sure it was network. Network is network LSA. Basically, what you have here is whoever the DR is, you're going to have whatever device this is going to be who's advertising it. So if it's R2 or R1, R1 will be advertising it. And so pretend like when you do have this and say this guy becomes the designated router, pretend like you have a R1-DR sitting in between the devices saying, this is what I have reachability towards. That's basically what the designated router is saying. This is what I know about on this particular link. And you can have, yeah, and what's cool about it is if you had a link to switch 7 and R1 had a connection down to R2, then the R1 might be the designated router for all of these. This could be a designated router connection as well. And then R1 could be the DR for all 3 links, because the designated router election is done on a per link basis. For every time you have a link, that interface will also be considered to be in the connection. So keep those things in mind. Type 3 LSAs is going to be the summary LSA. And this is going to be when you have a router that's acting as a border router. So if I have R1, R2, and I have R3, and I have a LAN segment hanging off of each, and this is area 0, and this is area 1. What will end up happening is this guy right here will be the area border router. And what will end up happening is you'll see router 2, we'll say this is the 11 network, and this is the 33 network. R2 will see the 11 network as an OSPF route, and he'll see the 33 network as an OSPF route. But R1 will see the 33 network as an OSPF inter-area route, and R3 will see the 11 network as an OSPF inter-area route. The inter-area pointer will be to R2 because router 2 is acting as the area border router. But router 2, since he's sitting in both areas at the same time, he'll see both routes coming in as an OSPF intra area. Now, these two LSAs, type 1 and type 2, only flood within inside of the area that they exist in. So these are area constrained, is what I'll say. Area constrained means that type 1 and type 2 LSAs don't the advertisements themselves, a type 1 LSA, will be propagated within inside of the area. Once that type 1 or type 2 LSA hits an area border router, when it goes from one area to the other, goes from area 1 to area 0, it's converted to a type 3 LSA because it must pass through the area border router in order to get to the other area. And this is where OSPF inter-area routing becomes like EIGRP with routing by rumor, because R2 is advertising to the routers in the other area, hey, in order to reach area 1 routes from area 0, go ahead and use R2. And same thing from R1 to R3. If R1 wants to reach R3, he must pass through or point towards R2 in order to get to where he's got to go. So that's basically how that works. And just to keep things from a forwarding perspective easy to understand, if you're trying to stay within your OSPF domain, so in OSPF, you will drop down in LSA types. So if I'm in a different area, I will use a type 3 LSA to reach a type 1 LSA. If I am going to be inside of OSPF, or if I'm leaving or going outside of OSPF, I'm going to go up an LSA because I need to go from either 1 to 5, which is going to be an external LSA, or a 3 to or it might be a 1 to 3 to 5, depending on the situation, 1 to 3 to 5, depending on where I'm at in the network. If I'm in area 0 and let's say R3 connects off to the internet, R2 is going to see this as an intra area external route, and you have type 4 and type 5. Type 5 is an external route, external LSA. And if you're a type 5 LSA and you're seeing a type 5 LSA, that means you are in the same area as the router that's advertising the external route. A type 4 LSA is an ASBR external or summary. And what that means is that I'm in a different area than the external, than the type 5 LSA. So if I'm R1 and I need to get to the internet, I must go from area 0 to area 1, or I'm sorry, area 1 to area 0, excuse me. And I need to go from here. So the area border router, the router 2, will actually generate a type 4 LSA and point that inbound towards R1. So R1 will see an ABR or an type 4 LSA that points to get to the the ABR, which is a type 3 LSA, and get it to where it's got to go. So I'm sorry, not the type 3 LSA. If it's an external route, you'll see a type 4 propagation LSA come through, and that'll be saying, hey, point to your ABR. The ABR will be able to reach the external route, is what that's saying. And that's basically how that'll come to be. So you have, this is what they refer to as an intra area, we'll say EXT, external, and this is 1 to 3 to 5 is an inter area external. If I have to leave my area to reach the router that's got the access to the default gateway, that's how that would work. Now there's a type 7 as well, which is a not so stubby area LSA. And this is typically done when you're dealing with any type of stub area, specifically not so stubby area and totally not so stubby area. They basically, when you're dealing with stubs, these specific LSA types are not allowed in stub areas, depending on how deep you go. So if you're dealing with just stub areas, you can't have type 4 and type 5 LSAs show up in your area. So if I converted area 1 to be a stub, you can't have type 4 and type 5 LSAs in a stub area. You can only have you can have type 1 and type 2 and type 3. And the type 3 is going to be a default route to get you to wherever you got to go. Where if I'm going to be using a totally stubby area, so you type in, the command would be stub no summary. You're getting rid of the type 3 LSA. So this would be also include all of this. So the first one is stub. The other one is stub no summary. And that would get rid of your type 3, 4, and 5 LSAs. And that's basically where that would come into play. Yeah, and that's typically because most people don't go this deep with CCNA for CCNA content. But this is the type of stuff that I really suggest from just knowing how the protocol works at a high level. This is some of the basic stuff that you would need to understand, because this is actually going to help you transition into CCNP much, much easier, right? If you understand this will make CCNP that much easier. The further you take your CCNA training, the easier CCNP will be to continue into. If you just take yourself to CCNA, like learn just enough, and I'm not exactly sure what that just enough level is, to be honest with you. If you learn just enough to pass your CCNA, CCNP will be extremely difficult to work through because you're still trying to build your knowledge level. But if you take your CCNA training and you just keep right on going, you're like, okay, I'm going to keep learning this protocol to the next step. The same thing with like PGP and IPsec and any other topics. You're going to find CCNP won't be that difficult, or it'll be actually easier because you've already covered that. That's the whole thing. So, yeah. So, and because you're at that point where you're feeling like you haven't quite earned it, or you're still kind of like not where you think you need to be, that's a fair assessment. I'm actually glad you're being that honest with yourself, because now you can say, you know what, I need to dive deeper into the protocol so I get a better understanding of it. So that's basically how that works. Now, in a stub area, no redistribution is supported in a stub, but in a not so stubby area, you can do redistribution. And that's why they call it not so stubby, because you're going to allow redistribution in. And that's why they have a type 7 LSA, because type 5 is not allowed. So you will have a type 7 LSA injected anyway, and you'll see it show up as NSSA. And then when you get to your ABR, wherever that might be sitting, you're going to have what they call a type 7 to type 5 translation, which means you're going to convert your type 7 to a type 5 LSA as it goes into the rest of the regular areas, because none of the other areas are going to understand type 7 LSAs because they are specific to not so stubby areas. So that's basically how that works. I can show you what that looks like in the config. It's not very difficult to do. It's only a handful of commands. It's the logic that you need to understand and what it is you're trying to control. It's all about trying to keep the link state database and the routing table as small as possible. Some people like to see lots and lots of routes show up in their routing tables. Other people want to have that bad boy as small as possible, because the smaller it is, the quicker reconvergence happens. So little things like that to keep in mind as you're going forward. But these are some of the details that you would need to understand if you're like trying to figure out how things work and stuff like that. And depending on how you're looking at them, you've got the OSPF state machine, you've got OSPF intra area routes. Actually, let me cover that real quick as well. So when you're dealing with any of this stuff, you're going to see, let me draw it over here where I have a little more room. From an order of precedence, which is the most important based off the propagation, you have OSPF routes, you have OSPF inter-area routes, you have OSPF external type 1, you have OSPF not so stubby area type 1, you have OSPF external type 2, and you have OSPF NSSA type 2. And that it processes top down. So the higher you are up in the area, so if you're in the area, it's going to be an OSPF route. That's the most preferred. And the cool thing about this is because this is how the OSPF processes the routing. It doesn't matter if you're learning a route for OSPF E1 and it's got a cost of 100, and you've got an OSPF internal inter-area route and it's got a cost of 1,000. You would think, oh, the lower cost would win, right? And that is not the case. The cost, you could throw even larger differences between the two, and the cost does not help here. This route will always be chosen before this route will, because it's higher up in the order of operations in the state machine, because it's the way that OSPF works. So there's a better way of explaining that, but at the moment I'm failing to remember the exact lingo. But you have to understand the OSPF state machine, and this right here ties into this over here when you're dealing with your connectivity. So I don't want to go much deeper than that because it gets complicated. But beyond that, that's kind of where we're at. So is that good? I mean, I don't want to say I don't want to go any deeper because I don't know how to explain it. But I'd have to. It's going to be very difficult for you to correlate what I'm talking about to anything unless you've seen it on the CLI and you tested it out. But I just don't want to lose anybody in that aspect, because if I continue to go down the theory wagon or the theory trail, I'm going to start losing people. So I want to jump in the config. I'm gone deeper than most people than I normally would have for CCNA, but some basic high-level information is good for everybody. So, all right, with that being said, I'm going to go ahead and switch gears. I'm going to jump on the CLI. I'm going to deploy OSPF. I'm going to show you kind of a transition way of configuring things, just so that in the event that you had a problem going on in the network, you'd still be able to get everything working. So we might lose some connections, but I mean, in a transition, a little bit of downtime is accepted. I'm going to go ahead and clear the screen, and I'm going to pull up Secure CRT and get this train rolling. So the first thing I'm going to do is I'm going to go and set up OSPF between R1 and switch 6, and then R2 and switch 7. On here, I'm going to type in router OSPF 1. And then the network statement is going to be 10.1.6.0, 0.0.0.255, and then area 0. I'm going to put everything in area 0 for right now. It'll just make more sense when we get a little further along. And then I can even throw the SVI connections into like area 1, for example. So you guys will be able to see how that comes into play. So I'm going to go over to switch 6 and get him configured. It'll be router OSPF 1, network of 10.1.6.0, 0.0.0.255, area 0. This will not form right away. This will take 40 seconds to happen, which is the actual designated router election process. And once that timer expires, the DR is figured out, and then the DR will be defined, and then the actual adjacency process will kick off. So while that's happening, I'm going to go get R2 done. I'm going to do router OSPF 1, network of 10.2.7.0, 0.0.0.255 area 0. And then on switch 7, same thing here. Router OSPF 1, SPF, not OSFP. 1, network of 10.2.7.0, 0.0.0.255 area 0. All right, so we saw that R1 popped up, and we have an adjacency with OSPF. If I do show IP OSPF interface brief, I can see that I'm working on gig 050. If I do an IP OSPF neighbors, you can see that I have a fully adjacent connection, and we are the designated router, and router 6 is in the state of full, but he is the backup designated router. If I go over here and do show IP OSPF interface brief, we can see that the state is currently BDR. If I come in here and do neighbor, we can see that we're connected to router 1, and he is the DR currently. If I do show IP OSPF database, you're going to see this. You're going to see the type 1 LSA right here. These are your type 1 LSAs, and you're going to see the type 2 LSAs, the network link states. Okay. And now switch 7 and router 2 also have that connection. The next thing I'm going to go do is I will configure switch 6 and switch 7 to advertise their SPIs in. So I'm going to type in network of 10.1, excuse me, 10.1.10.0, 0.0.0.255, area 0, and 20. Now if I hit the up arrow, I do show IP OSPF database, I'm going to start to see that coming through. Now you notice that the link count went from 1 to 3. That's because I'm advertising more routes. If I go over to R1 and I do show IP OSPF database, I'm going to see a total of 3 links coming across, right? If I do show IP OSPF database and I say for the router, I'm going to start to see this stuff coming across. I'm going to see 10.120 and 10.110. So I'm looking specifically at the router LSAs, and you can dive into this if you'd like. This is how you would do that. And you can get an idea of how everything is configured and good to go there. I'm not going to go very far into the OSPF database. It needs a deep dive in and of itself, and I don't have a whole lot of time left to go into it. I actually have a hard stop at 5:25. I have something I have to go take care of. So in what's that, about 45 minutes or so, 40 minutes, if I have a hard stop. But so that everybody good so far with the operations. Is very configuration wise is identical to EIGRP, right? There's nothing different other than the area configuration changes. That's it. On switch 7, I'm going to go ahead and set up the network statements for him as well. So network of 10.1.10.0, 0.0.0.255, and then the area command. And then we'll do the same thing for 20 and get them squared away. Now, we're going to have to go through the same process we did when we set up the R1 to switch 6 connectivity right here, as well as switch 7 to R2 with the adjacency. So they come online. Now, remember what I told you guys earlier about forming an adjacency between, good thing you get to go back and rewatch it again, huh? So, what we don't want to have on switch 7 and switch 6 is an adjacency forming between switch 6 and switch 7 when you've already got HSRP. So I'm going to type in the passive interface command, and we're going to say VLAN 10 and VLAN 20. That'll take the adjacency down. But it still advertises the route. All the passive interface does is it prevents the propagation and the reception of any type of OSPF hello. But the routes still propagate. That's the cool thing about it. Since it still propagates, you still get to maintain your reachability. So switch 6 will be the same thing. So type in passive interface, VLAN 10 and VLAN 20. Just like that. So routes are still going to advertise, but I won't have a connection between the two, which makes the most sense. You don't really need one in that case. Now, the big reason for that is if I had a link between R1 and R2, and I have a connection between switch 6 and switch 7, I run the potential possibility during a reconvergence event or a network device failure, a link getting pulled and then getting plugged back in. Anytime OSPF has to reconverge, you run the possibility of having a loop because you have a connection like this where it's going like that. You'd have a big loop between them, and that loop can go until OSPF figures itself out. Any loops that occur during reconvergence are often referred to as transient loops. Transient loop means that it's happening during reconvergence and it eventually will go away. A data plane loop is a misconfiguration of some type somewhere in the network. You've accidentally done something. Either you haven't done your filtering correctly during redistribution, or you've got some stuff going on that you shouldn't have. When you have a data plane loop that's consistent, that's different than reconvergence and having a transient loop. Transient loops eventually will figure themselves out, and OSPF will reconverge and be like, oh, yep, I don't need that link. I'm going to go shut it down. Or what path was making sense is now not making sense because it may not be as good as another path. And so that potential loop that you had will eventually go away. Just a couple things to keep in mind when you're dealing with connectivity, which is one of the reasons why we don't want an adjacency between switch 6 and switch 7. All right, now that I've got that, if I do show IP route, how come I don't have any OSPF adjacencies? Right? How come OSPF isn't showing up in my routing table? Any ideas? If I go to R1, same thing. How come do show IP route? How come I don't see any OSPF routes showing up? The answer to the question is because EIGRP is still active, yes, and the AD most likely, yep. Your static routes and EIGRP routes have lower, which will show up in exactly 100%. Pete's got the most specific answer, but yes, that is true. So if I go in to R1 and I type in no router EIGRP1, and I go to switch 6 and type in no router EIGRP1, switch 7, no router EIGRP1, and switch an R2, no router EIGRP1. All right. Now, if I go back to R1 and I hit the up arrow, I have OSPF routes showing up in my routing table, right? Now, if I go down to switch 6, if I do show IP route, I have no internet access, right? My gateway of last resort is not set. So how do I propagate a default route in OSPF down to my switches? How would I go about doing that? Any ideas? Exactly. Default information originate. You are spot on. So underneath router OSPF1, default dash information originate, and go back over to switch 6, and there it goes. Now I have my OSPF external type 2 route showing up. E2 is used by default, which is exactly what you want to see. And then I'm going to go ahead and same thing on R2. I'm going to type in router OSPF1 default dash information originate. I go to switch 7 and a do show IP route, and we see the route show up in the routing table. There we go, right? We have connectivity in place. Everybody's happy. So now the question is, will I have internet access? You betcha. because we've taken OSPF and we've done the same thing we did with EIGRP, right? Notice that I'm still sending traffic out towards switch 6. Switch 6 currently is my current active forwarder for both VLAN 10 and VLAN 20. In the event that switch 6 dies, switch 7 should take over. But they're both getting the same information. Make sense? Any questions on that? Good stuff. See, it's not super difficult, right? You get that part? Cool. Now, what I'm going to do now is I'm going to convert VLAN 10 and VLAN 20. Yeah, LSAs probably will be for a little while. You're probably going to have to read the documentation and have it labbed up. That'll definitely help, because in this topology here, I mean, I could make it work. I could show you how it works, but I think I would just confuse. Well, I don't want to say I would confuse you, but if it's hard to understand, that's going to be par for the course for right now. One thing I'm going to share with you guys is my my OSPF notes that I've got, and hopefully that will provide some clarity as to how each one works and how they come into play and stuff like that. Maybe that'll help you guys out. They're deep notes, but that's like me studying for my CCIE. That's basically what I used. I'll share my notes out to you guys, just so that, you know. And there's a lot of notes. Anyway, with that being said, I'm going to go on switch 6 and switch 7. If we look on router 1, if we do show IP route again, we can see that we're learning these in, but these are OSPF intra-area routes, which means we're inside of the same area. I'm going to go ahead and put VLAN 10 and VLAN 20 into area 10. Or no, actually, I'll do area 100. On switch 6, I'm going to do show run pipe section OSPF. And I'm going to type in router OSPF 1, network of 10.1.10.0, 0.0.0.255, area 100. And what you're going to see is that you'll see a syslog message saying it's been changed from area 0 to area 1. And I'll do the same thing for 20. And then I'll do the same thing on switch 7. Router OSPF 1, network of 10.1.10.0, 0.0.0.255, area 100. And 20. They're good to go. And then I'm going to go to R1, hit the up arrow. Now you'll see the OSPF area routes show up as inter area with IA. And that's basically how that'll work. So I just provided some connectivity, a multi-area deployment. And that's how simple areas are to work with. It's understanding what the different areas are and stuff like that, just a flooding domain. So that's that. I'm going to go ahead and flip switch 6 and R1, and then the connection between switch 7 and R2 over to IP OSPF network type point to point. Because if I do show IP OSPF database, I have this pesky little network link states here, right? I don't want that. I'm not a fan of the designated router. So what I'm going to do, I'm going to go to interface gig 0/0, and then I'm going to type in IP OSPF network, and I'm going to say the network point to point. Now, what you're going to see is this. You get right to here, it says OSPF network type mismatch received hello from 10.1.26, so which is going to be switch 6 on gig 0/0, indicating a potential network type mismatch. Because if we look at do show IP OSPF interface gig 0/0, we are running in the state of point-to-point. But if I go to switch 6 and I do show IP OSPF interface gig 0/3, I am running in the mode of right here, network type of broadcast. And therefore I have a DR priority, right? So I'm going to go and do the same thing here. I'm going to type in interface gig 0/3 and type in IP OSPF network type is going to be point-to-point. And then our adjacency will form again. Because now the network types match. And if I go back to R1, hit the up arrow, we're going to see point-to-point. Everybody's happy. I hit the up arrow again to go to my database. And now, guess what? My net link states, they're gone, right? They're gone. So technically speaking, I'm getting one from, why is that there? I shouldn't be getting that one. Let me go and convert this one over as well. Let's do, let's go take a look at R2 and do show IP OSPF database. Oh yeah, he's seeing R1. So let's go ahead and knock that out real quick. We're going to go to R2. We're going to go to interface gig 0/0 and type in IP OSPF network of point-to-point. And then on switch 7, we have to go underneath the interface VLAN to configure this. So interface VLAN 27. Whoops, 27. I'm going to type in IP OSPF network of point-to-point. Because we're using an SVI to terminate this and not a routed interface, we have to fix that. Now if I go back over to R2 and I look at the database, eventually this will time out. So we can see that the timers are looking better. So eventually this will time out because the age is so high. But right now we are still going to receive some network link states, but we're not receiving anything for the connection between the two, which is what we want to get. We got rid of that. So we're in good shape there. And if I was to hit the up arrow and go to the bottom here, we are receiving a default route. And you notice the tag number right here. This tag indicates that this is our process ID. So tag 1, process ID 1. If we go down to switch 6 and I do a show IP route, you'll see the default route. And if I look at show IP OSPF database, I'll see that tag 1 is coming across. And in order to reach the internet, I need to go towards this advertising router ID, which is going to be router 1. And that, ladies and gentlemen, I should say gentlemen because there's no ladies here. I keep saying that. That's pretty much it for the basics of OSPF. It's not a ton of, it's not super difficult. One second here. I have to. I'm going to cover, I'll cover ACLs. We'll do some basic connectivity tests between PC11 and PC13 just to block some connectivity. And that'll pretty much wrap up the call because I've got to jump off here pretty soon here. Any questions on any of the other stuff that I've covered? Anything doesn't make quite, it doesn't make a lot of sense. Take it easy, Omari. And yes, Pete, we can have more sessions like this soon. I don't know what my availability is going to look like. I will know that soon. But yeah, we will definitely be able to take a look at that for sure. But you're a YouTube subscriber, so you'll see stuff like this pop up, and I'll put a posting out there when we decide to go live on that. with the new job, I'm looking at doing some additional training stuff, but yeah, we'll definitely be able to do that. I don't teach cohorts anymore, which is nice. And I'm so tired of teaching cohorts. Anyway, that being said, no, your cohort was actually pretty tame. It's I left that organization and I went to a different one. I'll keep it simple like that because people aren't gonna recognize what I'm talking about in the replay. So, but you know where I'm coming from. That's the bottom line. You guys know what I'm talking about. Anyway, with that being said, I'm going to go ahead and cover ACLs real quick. Not a lot to dive into really, but we're going to make sure that we do this on switch 6. So because switch 6 is our default gateway, and that's where we'll have to configure them. So what I'll do is on switch 6 is I want to prevent PC11 from being able to ping PC13, right? Because right now PC11 can ping PC13. If I ping 10.1.20.1, I should be able to ping him as long as PC13 has got the IP.IP address, show IP. That's the right IP. Every once in a while this happens where I've got to go on the switch and I've got to ping the IP address, ping 10.1.20.1, and then now I should be able to ping between the two. There it goes. Every once in a while I have that problem. But what I'm going to do is I'm going to, and the same thing with 20.2. Kind of, yeah. Well, ARP should kick in, and sometimes it doesn't work in a virtual environment the way it should be, but it's working now. So what I'm going to do is on switch 6 is I'm going to create an extended ACL, say IP access list extended, and I'm going to call this block ICMP. Can't spell ICMP. And what I'm going to do is I'm going to say deny ICMP from the source, from the host of 10.1.10.1 to the host of 10.1.20.1 if it is echo or echo reply. But I'm going to say permit IP any. So do show IP access list. I have my entries in here where I'm saying I want to block ping from any from 10.1.10.1 to 10.1.21 and vice versa. So if I get a reply back, then it should get blocked. So if technically speaking, this line doesn't make any sense. Let me actually go ahead and get rid of it. Would never have. Yeah, I would. Actually, no, that'll work. Now that I think about it. So this is basically saying if 10.1.10.1 is trying to respond to 10.1.21 via echo reply, that will get blocked. How I apply this is I go to interface VLAN 10, and I can either apply it inbound on VLAN 10 or outbound on VLAN 20. Because we got to think of the direction of the traffic. Traffic will be coming in on VLAN 10 and then going back out on VLAN 20. So I can either block it inbound on the SBI on the receiving VLAN, or I can block it outbound on the outbound on the sending or to the VLAN that is being receiving the traffic. It's either way I can do it. I'm going to go ahead and do a IP access group, and I'm going to call this block ICMP in. Now if I go back over here, let's do a show IP access list real quick. We have no hits on it. I'm going to come over here to PC11 and try to ping 20.1. And I'm getting Communication administratively prohibited. And if I come over here to I have 5 matches. So the ping never made it through. But if I tried to ping, if I go from PC13 and I try to ping 10.1.10.1, notice that I'm getting an ICMP timeout. If I go back to here and I hit the up arrow, I'm getting matches right here. So 10.1.10.1 is responding to 10.1.21 via echo reply, and those matches are getting caught on because the ping is being dropped. The ping is actually getting from PC13 to PC11. So the echo is going out, right? And if I was to create another access list on switch 6, and say IP access list extended ICMP, and say permit ICMP from host 10.1.20.1 to host 10.1.20 or 10.1 via echo, and then do a permit IP any, and then go to interface VLAN 20 and type in IP access group in or ICMP inbound, and then do that thing again, do that ping. Still going to get timeouts, but if I go to the ACL, you're going to see that my ping is going out, so it's being received on the SVI of VLAN 20, and I'm blocking the response back out. So traffic is coming back in from PC 11 on the SVI of switch 6, and the ACL is actually dropping the traffic as it's coming back in because the source is 10.1.10.1, the destination is 10.1.21, and it's a response to an echo. It's an echo reply. So that just goes to show you that you can do it both ways, and that's where ACLs you have to play with them to understand their logic. Well, that's basically how that would come into play. But if I wanted to go to PC11 and do a ping to trace to quad 8, that's going to work all day. If I go back to PC13 and I wanted to trace to quad 8, I can still get there all day. Doesn't affect any of the traffic. This is more or less east-west traffic and how that would work. All right. Now, whether or not you use ICMP or you try to block HTTP to a web page or telnet to a remote management, or you block SSH, the logic is still the same. You still have to come in here and specify the protocol, which, like, for example, if it's going to be, if you want to block telnet from reaching something, you can say deny TCP from whatever the source is to whatever the destination is, and then you can say equal 23. And that would say, I want to deny telnet from this source to this destination, whatever that might be. And that's some of the cool stuff that you can do with ACLs. And I prefer extended ACLs anytime I can over a standard ACL because it doesn't matter where I put them. Now, technically speaking, you're supposed to put a standard ACL as close to the source as possible, so it's caught as quickly as possible. An extended ACL is supposed to be placed as close to the destination as possible. But in this case here, I only have one choice. The switch 6 has got the only SVI that I can apply an ACL to. And these are layer 3 access lists, so they have to be placed on a layer 3 interface. Clear as mud? Good to go? Questions on that? Before I wrap up, you get a good portion of it. Okay. Anything that doesn't make sense? For sure. Yeah, I agree with that. Nothing that totally doesn't make sense. More practice will help answer things much smoother. I agree. Yep. Practice, practice, practice. Practice makes permanent. Practice does not make perfect, because no one's perfect, right? There's always room for improvement. All right, gentlemen. Perfect never exists. Exactly. That's why you practice, practice, practice to make it permanent. And the one thing I like to say is when it comes to, let me go ahead and stop sharing for a minute here. The one thing I like to say, and this is something that I've listened to a lot of podcasts about when it comes to other occupation training. For specifically, I like listening to Navy SEAL podcasts. And one thing that I like, one thing that a lot of the guys say on a regular basis is that they spent like I guess I don't know what the actual term to call it, but let's say they call it a workup, where you spend 18 months getting ready to go on deployment, and then you spend 6 months on deployment. So you spend 3 times as much time training as you do actually doing the job, which I find that their occupation and the way that they train is very similar to the way that people in the IT space train. We spend a lot of time studying and a lot of time learning in order for us to do the little bit of work that we have to do. Sometimes it's can be challenging, and that's how you grow, right? You don't grow by staying in your comfort zone. You grow by getting out of your comfort zone and being challenged. So that's just something to keep in mind as well. But one of the things that he mentions a lot in his podcast, and I'm talking about Cleared Hot podcast, he mentions a lot about currency, meaning how current are you in that particular skill set. I would not consider myself current in a lot of routing and switching content. Do I still know it? Can I still execute on it? Sure. But do I consider myself current on it? Not really. I'm falling back to what I remember and what I can do on a basic level. But that's the key, though. It's mastering the basics, becoming good at doing the basic stuff. And then as you add another basic skill, like a particular like stub areas in OSPF, for example, when you add another, once you've got one basic level under wraps and you're good to go, you add another basic skill and another basic skill, and then it starts to build off of each other until you have a really strong base and you know a lot of different things. And then you can use that base understanding to take that into other things. Like once you guys are rock stars in CCNA and you've got that stuff locked down, it'll make things way, way easier if you, for example, wanted to dive into VMware networking, like NSX. If you have a strong baseline of computing on a computer, for example, and you want to get into virtualization, understanding how a CPU works and how the operating system interacts with the CPU and all the components on the motherboard will make understanding how virtualization works. So I look at it that way. A good mentor also would be huge for any newcomer. And then, yeah, I agree with that. But the only drawback to that thinking, and I'm not sure if a drawback would be the right term, but a good mentor will be able to provide you with advice and clarification, answer any questions that you might have. But a good mentor, you, regardless of how good the mentor is, you still have to put in the time. Because I know a lot of stuff, right? I can be a good mentor to others, but there's a mentor can only do so much for the person. The person has to have the will and the drive, which, I mean, you're here, it's clear that you have the will and the drive. It's just one of those things where you have to spend the time. And you've mentioned that several times so far, so I know you recognize that. But for those that are watching this in a recorded format, on a replay, it's important to keep that in mind. You know, I have one of my kids snowboards a lot in the wintertime, and he is good at snowboarding, and he's got coaches that are older and have more experience than him and show him little things. So he's gotten better and better as a snowboarder, but he's only gotten better and better because he puts the time in, and he's also got good mentors. So, but I agree with you. Good mentors also have a huge benefit to anyone new. And the thing is you'll become a good mentor as well. So at some point in time, you'll take all the experiences that you have and you'll be able to pass them down, which is why the IT space is very much a pay it forward kind of deal. Take what I've learned and pass it on, explain it, do my best to try to help others. So it all works out in the end, man. So good stuff. So I'm about to get an alert for you have a 30-minute extension. I'm going to go ahead and just close that message out. We are in the last 30 minutes of the call, but I have a hard stop in about 10 minutes. And I don't see, I'm not going to dive into any of the other, there's nothing more for me to really dive into. We covered everything that I wanted to today. And I'm glad we went slower and focused on just some of the basics. We didn't dive into anything advanced. I didn't go too fast, I don't think. At least I hope not. But we will definitely do this in the future. I will let everybody know how that's going to work out via YouTube and things like that. Okay, good. I'm glad that you were happy with the pace. So, good stuff. All right, gentlemen. And we'll do this in the future at some point. I don't know when, though. I'll let you guys know. But you guys have a good rest of your day. You can enjoy the rest of your weekend. Cool beans, hot rice. Ha, 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 ha. Good stuff. Can't say that I've ever had beans and rice. Not a big fan of beans. But anyway, so you guys have a nice rest of your weekend. And I will see all of you at some point in the future. Take it easy, guys.